today, and that's this. I thought this was on Fridays. These two terms here will get mixed up, so you need to pay attention to them to make sure you keep them straight, okay? Supplementary angles and complementary. Complementary angles are two angles that add up to be 90 degrees. Complementary angles add up to be 90 degrees. Supplementary angles add up to be 180. This is one of the most easily confused sets of terms that we will cover. Supplementary and complementary. Sup and com. That's the only real difference between the two in name. Complementary, two positive angles whose measures have a sum of 90 degrees. Supplementary, two positive angles whose measure have a sum of 180. So again, both of them are talking about two angles. One adds up to 90, one adds up to 180. So if you can figure out a trick or a kind of mnemonic, some way to keep it straight, that will be great. Guys, Chromebooks, shut, 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 shut. Thank you. So, supplementary and complementary. Complementary adds up to 90, supplementary adds up to 180. So I would find some way that you can keep those two straight in your head. Because it is very easy to get these two flipped. It's so easy to get these two flipped if you're not paying attention. I do it all the time. Well, I've done it multiple times because it's easy to get them flipped. Easy to get them flipped. You don't have to write the whole thing down. Really, I would just try to keep straight. Complementary angles add up to 90. Supplementary angles add up to 180. Adjacent angles. Complementary angles and supplementary angles can be adjacent or non-adjacent angles. Adjacent angles are two angles that share a common vertex and side, but have no common interior points. Adjacent angles share a vertex and a side, but have no common interior points. Share a common vertex and a common side, but no common interior points. So that little drawing I added down at the bottom, ABD and ABC, would those be adjacent angles? So what's ABD? ABD, AB, this ABD is this angle right here. ABC, do those have common interior points? Yes, so would they be adjacent? Yes. Adjacent angles are two angles that share a common vertex and side, but have what? No common interior points. That means one of those angles cannot be inside the other. For them to be adjacent, they cannot be inside the other because ABD is inside of ABC, isn't it? It is not adjacent. Adjacent means next to. They're pretty much right next to each other. Because as we look at this here, all the points here and all the points here do not overlap, do they? In those two angles, so they're adjacent, they're next to each other. That's all it's really talking about, adjacent, they're next to each other. They share a common vertex and a common side. These two here are not adjacent angles. The two we described down here, these are not adjacent angles. Adjacent means they just are next to each other. They share a common vertex and a common side. And that's it. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So we're going to name three things. So our first one, complementary angles. I'm going to call it letter A. Complementary angles. That's not good. Kelly, what does it mean for two angles to be complementary? They do what? You look at your note sheet. They add up to be 90 degrees. So if we want to find a pair of complementary angles, we want to find two angles that add up to be 90. So looking at these angles here, which two add up to be 90? These two here. Now, if you did angle BAC or angle TSR, those are the same things. But the main thing we're worried about is the fact that 37 plus 53 is equal to 90. So these are complementary angles. Now we want to find two supplementary angles. Two supplementary angles. CAD and RST, because 127 plus 53 is 180, because supplementary angles add up to be 180 degrees. Any questions on either one of these here? Okay. Well, we have one last thing. Are adjacent angles. So adjacent angles do what? They share a common vertex and a common side, but no common interior points. So what would be our two adjacent angles? Angle what? CAD and angle what? CAB. Do RST and CAD have a common vertex? Well, no, they don't have a common vertex. A common vertex is what? A point that the two rays connect. So S would be our vertex here. Point A is the vertex for these two here. So CAD and CAB share a common vertex at point A common side, a common ray, which is AC, but no common interior points. There's no points in here or here that they both share, they both have in common. So these two here would be considered adjacent angles. Questions on this here? Questions on this here? You good with this here? You ready for the next one? All right, let's look at the next one. Angle 1 is a complement of angle 2, and the measure of angle 1 is 62 degrees. What is the measure of angle 2? Huh? So, Brittany, what does it mean if we're saying that angle 1 and angle 2 are complements? They add up to 90 degrees. So what we're saying is that angle 1 plus angle 2 is equal to 90 degrees, because complement or complementary angles add up to be 90 degrees, yes? Complementary angles add up to 90. Supplementary angles add up to 180. Then what did it tell us? The measure of angle 1 is what? So angle 1 is, what do I have to do to find the measure of angle 2? 90 minus 62. We can subtract 62 from both sides. Which tells us that the measure of angle 2 is equal to 28 degrees. That's it. So as I've said already and a few times before, knowing these definitions is going to be key and remembering what they are. Is anywhere in this problem did it tell us what complement was? No, we had to remember what complementary angles, complement angles means that they add up to 90 to find out what it is. Questions on this here? Angle 3 is a supplement of angle 4. What is the measure of angle 4? So Jesse, what does it mean if two angles are supplement? They supplement each other? They add up to 180, yes. So we know that angle 3, so the measure of angle 3, so really I should have written the last one as like this here. Measure of angle 3 plus the measure of angle 4 is equal to 180. Well, it told us angle 4 is what? 47, yes? So the measure of angle 3 plus 47 degrees is equal to 180. So what do I need to do to find the measure of angle 3? We subtract 47 from 180, and we get that the measure of angle 3 is 133 degrees. 180 minus 47 should be 133. Questions on this here? These aren't too bad. Let's go on and do this one, because again, I think we need another example of this here. Complementary angles. So looking at this figure here, what two angles would be complementary to each other? Complementary means what? They add up to be 90 degrees. So these two here would add up to 90, because 41 and 49 do add up to be 90 degrees. And if you're not for sure, I would go on and try plugging them into a calculator and seeing yes if they do. Because there might be one on the homework assignment that looks like it should be, and it's going to be like 1 degree off. Like they could have thrown one up there that was like 50 or 47 to kind of mess you up a little bit. Yeah, this is not showing up on there.
No, it is. But like
Oh,
from
the-
the side.
Oh, the pages are out of order?
Yeah.
Okay, they got mixed up. It probably dropped the note sheet at one point. Yeah, they're... Yeah, I think I might have switched the slides out of order. I like that better. Supplementary. So what would be our supplementary angles? FGH?
Yeah.
What do FGH? Because FGH would have been this whole thing, which would be 172. So instead of using F, we can use K, which will give us that 131, which we want. Any questions on any of this here? We good with this here? Except for the fact the note sheet's way out of order, or the slides are way out of order. Huh?
I'm pretty sure there's.
Well, luckily this is always going to be on YouTube so that you can go back and look at it if you have questions. Adjacent angles would be FGK and what? Angle HGK, because these are the only two that share a common vertex and a common side. Questions on this here? You good with this here? You good for the next slide? So luckily this one should be right below it, yes? Okay, good. Are angles KGH and LKJ adjacent angles? So KGH and LKG, are those adjacent angles? So for them to be adjacent angles, they need two main things. What? A common vertex and a common, do they have a common side? Well, yeah, they share KG, but are their vertexes the same? No. One of them is at K, one of them is at G. So this is, no, they're not. The next one was our FGK and FGH adjacent angles. Do they have a common side? Yeah, they do. Do they have a common vertex? So are they adjacent? Correct. These are not adjacent. Because what did it say? Adjacent angles share a common vertex and a common side, but no common interior points. Because FGK, interior are these points here, yes? FGH is this here. Those are shared, aren't they? They overlap. So these here are not adjacent angles because they share interior points. Questions on this here? Yeah, I know these slides are all mixed up because this is probably forward or backwards, one of the two. Nope, we're still going this way. Yeah, this is probably on the next one. Are there any questions about complement and supplementary angles, two angles being added together? Are we good with these here?
Yes.
Yes? You want to see one more? So what does complement mean? It adds up to 90 degrees. So what do we know about the two angles? Measure of angle 1 plus the measure of angle 2 is equal to? So it told us the measure of angle 2 is 5 degrees. So we can subtract 5 from 90, which would tell us that the measure of angle 1 is 85 degrees. Because 85 plus 5 will give us 90. Because they are complements. They're complementary angles. Any questions on this here? So the next one is supplementary, which means these two add up to be what? 180. So angle 3 plus angle 4 is equal to, well, this one's, we do what? Subtract 148 from both sides, which tells us that the measure of angle 4 is 32, I believe. And again, if you need to use a calculator, use a calculator. There's nothing wrong with using a calculator. We got Elizabeth? Click. Any questions on this here? We good with all this here so far? Not too bad as long as we remember the definitions? Yes? Real world application, real world view right here. Ready? When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of BCE and the measure of ECD. Well, what do we know about these two angles? They do what? They add up to be? Well, one of them is what? 4x plus 8, and the other is? And what do we say? They add up to be? So even though we don't have numbers this time like we did on the last few, they still add up to be what? 180. So what we've written now is an equation where we're solving for the value of x, yes? Any questions on how we set this up? We good with setting this up? We're going to combine like terms. Well, 4x and x are like terms, yes? 4x plus x is? 8 and 2 are like terms, yes? Equals? What do we do next? Caleb? What do we do next? Minus 10 from 180. What do we get? Last but not least, what do we do? Divide by 5 is equal to zero to 15, 17. Yep. So 34 is the values that we were looking for. Yes, those are our two angles. No, that's the value of what? X. 34 is the value of x. What is this angle here? 4x plus 8, yes? So if I wanted to find the value of BCE, I'm going to have to plug it back in. I've got to do 4 times 34 plus 8. Do we have to do this by hand? No, we can plug this into a calculator. There's nothing wrong with that. I'm going to do it by hand. 4 times 4 is 6, carry the 1. 136 plus 8 is equal to 144. So the measure of angle BCE is what? 144. What do I know about the other angle? It's going to add to it to be what? 180. So there's two ways I can find the other one. Is that I can subtract 144 from 180, or I can plug it in. 34 plus 2 is 36. 36 and 144 do give me 180, yes? And that's it. That's all we have to do for this here. Questions on this here? And I think that brings us to the last problem. Yes? Oh yeah, we've got one more set after this. Okay. So there's another vertical angles, I forgot about them. But these here. So what does it mean if they are complementary angles? They add up to 90. So what are our two angles? LNM and PQR. Well, LMN is what? So if we add these two together, they equal 90. They equal 90. Because that's just what it told us. It told us that they were complementary angles, so they add together to be 90. So we have 4x minus 2 plus 9x plus 1 is equal to 90. Our first thing we can do is we can combine like terms, our x's. 4x plus 9x is? Negative 2 and 1 are like terms, so we get minus 1. What can we do next? Our next step would be add 1 to both sides, so we get x by itself. These cancel, leaving me with 13x on the left side, and on the right side I have. We divide both sides by 13. I want to say 7. 1, carry the 2, 7. Yep, 7. And again, I would just type that into a calculator, 91 divided by 13, because that's not one that you have memorized at all. Because I don't think many people memorize their 13s. Questions on this here? We good with this here? Yes? Reset. So the last thing we've got to do is we've got to what? Plug it back in. So we have to do 4 times 13 minus 2. Well, 4 times 13 is 2, carry the 1, 52. Minus 2 is 50. So the measure of LMN is 7. That makes more sense. I'm like, that is a big number. Thank you. We divided by 13 to get 7. So that's going to make more sense. So we should have 4 times 7 minus 2. 4 times 7 should give us 28. Minus 2 should give us 26. And then we'll have to do 9 times 7 plus 1. 9 times 7 is 63. Plus 1 is 64. Any questions on any of this here? You good, Eric? Am I going too fast for anybody? No, we're good? Yes? If I get going too fast, someone tell me to slow down. Any questions on any of this here? Linear pair and vertical angles. Two adjacent angles are a linear pair when their non-common sides are opposite rays. The angles in a linear pair are supplementary angles. Two angles make a straight line, they add up to be 180. Linear pair. Two angles that make a straight line add up to be 180. Yes? Shared sides, straight line. Angles, they add up to be 180. Add up to be 180. Two angles are vertical angles when where side forms two pairs of opposite rays. So we're talking about two lines that cross each other. The angles that are opposite each other are vertical angles. So 4 and 5, 3 and 6. These sets of angles are vertical angles. Now, If it's more than two angles that make the straight line, they're not a linear pair. Pair has to be two. Yes? Pair is always two. We pair things together in sets of two. We don't have three socks in a pair, do you? That'd be a little weird. Only two. Two comes in pairs. Two angles that make a straight line are a linear pair. Linear pairs are supplementary angles because they add up to be 180. Vertical angles, when their sides form two pairs of opposite rays. 3 and 6, 4 and 5. So the first thing we're going to do here with this next one, is we're going to identify all sets, all linear pairs. Linear pairs, so two angles that add up to be 180, two angles that make a straight line. Yes? I'll tell you, one of them is 1 and what? Angle 1 and angle what make a linear pair? It wouldn't be angle 3 because there's angle 2 here in the middle, yes? 1 and 3 don't quite work because we need a straight line. So it'd be 1 and 4. We have a straight line and two angles, yes? Make a straight line. Two angles that make a straight line. So 1 and 4 work. There's another one. There's only two. 5 and not 3. Almost. 5 and 4. 5 and 1 wouldn't work because they don't make a straight line, do they? So they need to be right next to each other and make a straight line. Now, if it wasn't the fact that 2 and 3 were split like they are, then we could do it that direction. But because of this line right here, it messes up those. They can't be a linear pair because we don't have two angles, yes? Now, if we had a way of naming this angle as a whole angle, then we could, because that would be 1, and we'd have that combination 2 and 3, yes? Do y'all see the difference there? But because I don't have a way of naming the sum of 2 and 3, I can't call it a linear pair because we just have two angles there. There's not a way to name it as a whole. Questions on this here? Now, vertical angles whose sides form opposite rays. There is only one set of vertical angles here. Y'all know what they are? This is linear. It's going to be angles 1 and angle what? 5. This here is a pair of opposite rays. Here's a pair of opposite rays, and that's the only two we can set up. Because of that one that splits 2 and 3 apart, messes it up. Because if that wasn't there, then that combination of 2 and 3 and 4 would be vertical angles. They would be vertical angles if this line wasn't here. If that line wasn't there, then it would work. But because it's there, it splits those apart. Questions on this here? Any questions on anything we've covered here? Yes? No? You good with this? Okay. We're going to skip that one. I'm not going to worry about that one. So this here is the one I want to look at. Let me guess this isn't showing up. No. There it is, number 6. So 2 parts. Do any of the number of angles in the figure form a linear pair? What do you think? Do we have any linear pairs here? Are there any two angles that make a straight line? What do you think, Eric? Two angles form a straight line.
One right there.
Which one? I mean, all of them do form a straight line at some point, yes? Do we have two angles that form a straight line? So let's say one. One and what number other angle form a straight line?
Oh, then no.
Well, no, we need at least how many? Three, yes? So do we have linear pairs? No, because linear pairs only need two. Linear pair means two. So there's no way to draw a linear pair with this setup because we would need at least three. We need exactly three angles to make a straight line. So this here has none. There are no linear pairs in this here because they just don't work. They don't make a straight line. Vertical angles. There are several. So let's just start with one. So this line here and this line here are opposite rays, yes? Because they make a straight line. These two here are opposite rays, yes? We have one more set. These here are opposite rays. So we have several vertical angles, don't we? So I'm going to start off with angle 1. Angle 1 and angle what are vertical angles? 4, yes. Because their sides form two pairs of opposite rays, yes? Let's name another, because there's two more. What's another set? You have one, Allison? You have a guess? 2 and 5. And then we have 6 and 3. And that's it. Those are the three. I mean, we could repeat the numbers, but they're going to be the same thing. And that's it. Questions on this here? We good with this here? Yeah, I'm not going to worry about either one of those. And they shouldn't show up on the homework. I will double check to make sure. Interpret the diagram. There are some things we can conclude, and there are some things we can't. It's just how it works. There's some things you can conclude. So looking at this diagram, all points shown on this diagram are coplanar. Coplanar means they're on the same what? Same plane. So we can conclude that. We can conclude that points A, B, and C are collinear, and B is between A and C. They're on a straight line, and B is in the middle. We can see that, yes? So we can conclude that AC is a line, BD is a ray, and BE is a ray. That's literally what we can see, yes? Angle BDE and angle BEBC are adjacent angles. So DBE, EBC are adjacent angles. They're next to each other. And angle ABC is a straight line. Anybody's mind blown yet? Those are lies. We're moving on. Point E is in the interior of angle BDBC. Y'all have a good rest of your day. The assignment should be up there for Big Ideas Math. And your test is Friday. Your test is Friday.